We're in Module 7. We're looking at the novice problem solution for problem number 1. This is the section where we're talking about linear programming. And as you know, linear programming is a decision-making mechanism that uses optimization. A linear program has a very specific sort of structure. There's an objective function that defines what we'd like to either minimize or maximize related to optimization. Sometimes we can set it to a particular value too, for example 0. Then we have a group of constraints that say here's the reality of the problem. We'd like to minimize and maximize, but they have to be subject to these constraints. And then of course there are decision variables, and decision variables are how we define our objective function and our constraints, and we have to define those early in the process. So let's go to our problem. We're looking at a situation where we have a small consulting firm and they're trying to do some planning for the future. They're in the fortuitous situation where they can kind of pick and choose projects because they're very good at what they do. And this small firm deals with 4 different types of projects, project 1 through 4. And there are a number of projects that are available for each one of the projects. And what we have to do is, based upon the profitability or the revenue generation capability of each project and the use of resources associated with the projects, we want to pick the number of projects of each type that maximizes our objective function, which is a revenue function, but it does so by considering the resource scarcity that we have. By that I mean we use up resource elements each time we pick a project, and we have to account for that. We don't have unlimited resources. Nobody's got unlimited resources. So the problem states that there is a table on the right here that describes the situation for both the objective function and the constraints. The decision variables in this problem are going to be x1 through x4. x1 will be a variable that says how many of project type 1 am I going to accept? 5, 10, 15. And remember, in linear programming, we can get values of projects that are decimal values, fractional values. It's one of the a bit of a problem for linear programming, but of course, you know, it's not that big a problem. We can always round and see how rounding affects the optimal solution. So that's our decision variable. X1 would be the number of project type 1 that I'm going to accept. It has a revenue generation capability of $45,000 per project. Project 2 has revenue capabilities of $63,000 per project. So obviously I'd like to do as many of this project as I possibly can, but you can also see that associated with the this type of project is pretty heavy usage of resources. We have 4 types of resources. They could we explain in the problem that they are different types of capabilities. Maybe they could be hours used in the production of a project. So the numbers here are larger than any of the other rows of numbers. Although we get a lot of revenue per project, we also use up a lot of resources. So how do we organize this thing into a linear program? Well, the objective function is pretty simple, right? We want to select the number of x1, x2, x3, and x4 that optimizes or maximizes the revenue of a project. And we can do so by organizing it in the following fashion. 45,000, this is a coefficient, 45,000 times x1, 63,000 times x2, etc., will give us the revenue that's generated. So if I choose 14 project 1, we're going to have 45,000 times 14. If I choose 8 projects 2, we'll have 8 times 63,000, so on and so forth. So we will make our selections of x1, x2, x3, and x4 to try to maximize this objective function. We often call this objective function z. So how do we constrain that to account for the resources that are available and that are scarce? Well, every project 1 uses 3 units of resource A. Every project 1 uses 3 resources of unit B, etc. The total resources that are available for A are 450, for B 490, 360 for C, and 285 for resource D. So how do I write a linear relationship, a simple algebraic function, linear function, that accounts for the use of resource A and says, hey, you can't use any more than 450. Okay, this is how we allocate our resources. This problem is really a kind of a resource allocation problem. The way we do that is we create, first of all, a set of 2 different kinds of constraints. Here is ST means subject to. So our objective function is subject to these constraints. Notice these values down here. x1 must be less than or equal to 25. x2 must be less than or equal to 30, etc. here. And all that is saying is that, hey, we don't have any more than 25 project 1s. We don't have any more than 30 project 2s, so I can do up to 30 or less, but can't do more. And that's where we account for this, this constraint in the number of projects. The allocation of resources is done a little differently. 3 times x1, 9 times x2, 3 times x3, and 4 times x4 is the way we consume our resource A. So x1 projects take 3, x2 projects take 9, x3 projects take 3 units of resource, x4 projects take 4. So if I multiply those variables, the quantity of projects that I'm going to take, and I multiply them times this coefficient, that summation of those variables cannot exceed 450. So that's where we have our first constraint. 3, x1, 9, x2, etc. must be less than or equal to 450. The second constraint is how we use up our resources for resource B. 3 times x1, 4 times x2, 3 times x3, etc. must be less than or equal to 490. And we can see that constraint right here, 490, 360. So we've organized the data in a very nice fashion so we can take our constraints, construct a constraint set, the subject to elements here that constrain the allocation of projects in the objective function. We also define our variables as the number of projects of type 1 selected, type 2 selected, etc. We can also, it is understood that we're not going to have negative projects. So the smallest project selection, x1, will be 0, but it cannot be negative. All right, that is a very simple explanation of how we construct a maximization problem in this resource allocation type problem in problem 1, module 7 in our novice workbook.